In this video, we will touch on how to find partial derivative. This question is asking for f sub x, f sub y as the first derivative. So f sub x will assume that 2 and y are constants and you have to differentiate x squared. And if you do that, the derivative will be 2 times 2x times y. And likewise, it's going to assume that y to the 4 is a constant. So if you differentiate with respect to x, you will get 2x on this side. And 5 we all know is a constant, so the derivative is 0. Simplify that a little bit, and it looks like if you have to find f sub y, then x will be momentarily a constant, and so would x squared and 2x squared. X squared will be momentarily a constant, and if you do that, the derivative will be the same constant for 2x squared y. But for the second one, we have 4y cubed times that constant x squared. 5 will still have derivative 0, and if I erase that, then that will be my answer for f with derivative, f's partial derivative with respect to y. To find f sub xy, it's the same as taking f sub x and then differentiate with respect to y. So we are taking this guy, which is a function of two variables, and try to differentiate with respect to y. So momentarily, 4x will be a constant, and 2x will be a constant. So the partial derivative with respect to y will look like 4x, because the derivative of y is 1, 2x times 4y cubed. So if we were to tidy this up, we will get if we have to find fxx, then we are taking the original function f sub x and differentiate with respect to x. So this thing with respect to x will keep y constant, and then we are going to get four, and then times y, 2, and then times y to the 4. Okay. The last one is to find fyy. So we are going to take this function as a function of two variables and differentiate with respect to y. So I'm going to squeeze the answer somewhere here, fyy. The first term is 2x squared, and the derivative will be 0. So the second term is 4y cubed, and that will have a derivative of 12y squared. And then x squared being a constant will just be attached to it over here. And that's how you find the partial derivative fyy.